In this section, we're going to begin looking at exponential functions and their graphs. And you've probably heard the term exponential function a lot lately if you've been watching the news at all, because the spread of this coronavirus follows an exponential function or an exponential curve. Starts off spreading very, very slowly, but the more time goes on, that curve begins to increase very rapidly. And so exponential functions are used to model a lot of different situations. For instance, the spread of a virus. We also use exponential functions in banking applications and in interest applications. So there are going to be a lot of things that we see that we can use exponential functions with. But just to define an exponential function, it's going to look like f of x equals, we can just use a to the x, where a is our base. It has to be greater than 0. We cannot have a negative number as your base. You cannot have 1 as your, 0 as your base. It has to be greater than 0. It cannot be 1. And it's called the exponential function with base a. It's an exponential function with base a. You notice I have a lot of graph paper on the side. We're going to graph some of these exponential functions. Just in contrast, just so that you will not be confused, if we have f of x equals x to the fifth, notice that is not an exponential function. For us to have an exponential function, the variable is in the exponent. Kind of helps give us that clue there. The variable is in the exponent, and I just misspelled exponential. So how about if I just abbreviate? Well, we'll come back here. Expo. All right, so f of x equals x to the fifth is not an exponential function. However, f of x equals a to the x equals an exponential function. Now, I want us to look at some graphs of exponential functions. And since I don't have easy access to the calculator on this particular app, we're just going to do it the old way by making a chart, and we'll figure out what that exponential function looks like. Let's start with a very simple one, a very basic one. We're going to do f of x equals 2 to the x. Remember, f of x and y represent the same thing. So if we do our chart, our xy chart, or you could put f of x here. Remember, that's equal to 2 to the x. We're going to do some on the negative side of the y-axis and some on the positive side. So let's just start with negative 2. You're going to be doing some graphs on your homework, and there is some grid paper that is available in your document section on RenWeb. I'm going to find negative 1 when x is 0, when x is 1, and when x is 2. So I would expect you to use these points, or at least have 5 points that are represented in your T-chart when you're asked to do the graph based on ordered pairs. So if we plug in on the y value, we get 2 to the negative 2. Remember, that negative exponent means it moves to the denominator, so that's equal to 1/4. 2 to the negative 1 is 1/2. Anything to the 0 power is always 1. And then we would have 2 to the first and 2 squared, which is 4. So now we can plot these points. Let me change my color. And make this a little bit bigger. Let's see what that looks like. You're going to see that a lot of these look very, very similar. So if we have the point negative 2, 1/4, negative 1, 1/2, a little bit hard to get it with, and then 0, 1. That's always going to look familiar. We have 1, 2. And then we're going to have 2, 4. Notice it begins to get steeper more quickly. If we did 3, 3 squared is 9. So I'm just so we can see what that's going to look like. Notice how quickly that begins to increase. We will never, unless there is a shift, we will never go below the x-axis. We have a horizontal asymptote at the x-axis here. Now, if we add something to the end of the function, that may change, but notice this is what f of x equals 2 to the x should look like. It is an increasing function. It has a horizontal asymptote at y equals 0. We cross the y-axis. It contains the point 0, 1. And the domain is all real numbers. And the range is from 0 to infinity. Notice it cannot include 0. But that's characteristics of this particular function, f of x equals 2 to the x. All right, let's look at this particular function, f of x equals 1/2 to the x. Now remember that we could write this as, this base is still greater than 0, but we could rewrite this as 2 to the negative x. Those are the same thing. I just want you to realize that those are the same value. 1/2 to the x and 2 to the negative x are the same. But let's look at the points that we would get if we have a base of 1/2. Okay, we're going to do these same values that we did before. Now this would, if we rewrite this as 2 to the negative x, this would become negative 2 to the negative, the opposite of negative 2. I'm sorry, that's not a negative there. We can't have a negative base. We would have negative 2, or we would have 2 to the opposite of negative 2, which is 2 squared. We would have 2 to the opposite of a negative 1, which is just 2 to the first power. We would have 2 to the 0, which is 1. 1/2 to the x is just 1/2, or 2 to the negative 1. And this would be 1/4. Notice if you look at your previous t-chart, instead of increasing slowly and then rapidly, we decrease. So let's see what this looks like if we graph these. And I'll just use the same grid paper, but we'll do a different color so we can see the difference. Let's do this one in red. We're going to have negative 2, 4. We'll have negative 1, 2. Still going to cross at the same point, but our values here get very close to the x-axis. So this function, and we'll have 3, 9, so let me go ahead just to keep from getting too far off, it's going to look like this. Notice that this function, when we have a fraction as a base, this function is decreasing. And also, we still have the same horizontal asymptote at y equals 0. We still contain the point 0, 1, and we have the same domain and range. Negative infinity to positive infinity for the domain, and the range is 0 to infinity. These will come in handy to know when we get to the section on the inverses for these exponential functions. Notice that both of these functions are continuous functions. These are continuous functions, and they are one-to-one. They're one-to-one functions, which means that they do have inverse functions. We see that if a is greater than 1, if the base is greater than 1, the function increases. If the function is if the base is between 0 and 1, the function decreases. We've already talked about the domain and range. The domain is negative infinity to positive infinity. The range is 0 to infinity. And we always contain the point 0, 1. And in this case, the horizontal asymptote is the x-axis, or the equation y equals 0. Now, last semester you talked about transformations of graphs, and these same types of transformations take place even with exponential functions. For instance, if I want to graph f of x equals 2 to the x minus 2, this x minus 2 in the exponent means everything shifts 2 units to the right. So I'm going to see if I can graph this without doing a new chart. I know that I have the point 0, 1. Well, that is going to shift 2 units to the right. So I'm going to have the point 2, 1. This point at 1, 2, that's going to shift 2 units to the right. So it's going to be right here. And then 2, 4 shifts 2 units to the right. So 1, 2. And we still approach the x-axis. Here, this is going to this 1/2 is shifts 2 units to the right. And so this graph, everything is just shifted over 2 units to the right. This is f of x equals 2 to the x minus 2. If we wanted to look at f of x equals 2 to the x minus 4, let me actually do a different color here. We'll do that one in green. That shifts everything down 4 units from our original graph. So if I go back to the original, which is in blue, this point is going to go down 4 units. So from, it was 0, 1, so we're going to count down 4. It's going to be 0, negative 3. We were at 1, 2, so that's going to go down 4. So we're going to be at 1, negative 2. We'll be at 2, 0. And our new horizontal axis shifts down 4. So it was y equals 0, so now it's going to be y equals negative 4. So we could actually draw one in, but that's what we're going to approach, is y equals negative 4. And I'm hoping I can get it right on here, there. Then it begins to increase very rapidly. So those transformations that worked with other graphs work the same way. If we have the negative in front of the base, then it's going to reflect across the x-axis. Okay, let's look at f of x equals a negative 2 to the x. Well, everything is just going to reflect across the x-axis. This point comes here. This point moves here. This point, the